I'd like to demonstrate the process of online migration of a volume from traditional CloudStack storage to CloudStack managed storage. Now first, before I get into this, let me demonstrate what kind of an environment we're working in here. I just have a single zone, single pod, one XenServer cluster with two hosts, one and only primary storage right now, which is NFS based, and I've got my system VMs up and running. So let's go to the service offerings area first of all and create a compute offering. Upper right hand corner, I hit compute offering. Let's give it a name, just CO1, compute offering 1 sounds good. We'll just put that in for the description. Something very basic here, 1 core at 200 megahertz, 128 megs of RAM. And the rest of this I'm just going to leave empty. I'm going to hit the OK button. And then in a moment I'll have my compute offering. There it is. Now let's go over to the Instances tab. I clicked on that in the upper right. I'll click on Add Instance. I'm going to create a VM based on a template. I just have one XenServer template. I'll hit the Next button. Just have one compute offering, the one that we just created. I'll hit Next. And then I'm just going to hit Next through the rest of these windows. I'm going to come to the Review section. I'll pick a name like, let's see, VM XS1, so Virtual Machine XenServer 1. And then I'll click on the Launch VM button. So let's switch over to I have a Windows VM running XenCenter, and we can see right here, I'll highlight it. Our virtual machine is in the process. It is actually up and running right now. If I click on this SR, this is the one and only shared SR that both of my XenServer hosts have access to. We can see it's highlighted on the right-hand side, a root 10, 20 gigabytes in size, is attached to the virtual machine that we just kicked off. So everything looks good here. We have our root disk of our VM on an NFS SR that's shared between our two XenServer hosts. Let's switch back over to the CloudStack GUI. I'm going to click on the Instances tab to refresh that window. And our VM we can see here is up and running. If I go over to the Quick View column and click on View Console, we should be able to see that we have booted up. So everything looks good here. Let's exit out of this window now. And I'm going to click on the name of this virtual machine. I'll click on the View Volumes hyperlink. And we can see that this particular virtual machine just has a single virtual disk. This is the root disk of our VM. Now, as we can see, and I'll switch back to my Windows VM that's running XenCenter, we can see, and it's highlighted here, root-10, this particular virtual disk resides in an NFS SR alongside other virtual disks. Now in this particular case, my NFS SR, the share itself does not have any performance guarantees associated with it, and we don't have any particular quality of service running so at the share level or then even at the virtual machine level, at the virtual disk level. So we really don't know what kind of performance to expect from any of these virtual disks. Let's say we have a critical application here that we're running within this particular virtual machine, and we would actually like to make sure that the virtual disk of this particular virtual machine is running on storage that can guarantee performance. To do that, we're going to need to migrate this virtual disk from this NFS SR to what CloudStack calls managed storage. Now in our case, it's managed storage that's backed by the SolidFire storage plugin, which is what controls access to our backend SolidFire cluster. And that SolidFire cluster, each and every volume on that cluster can have QoS controls configured in a very fine-grained fashion. So if we have a SolidFire volume, on that SolidFire volume, we'll have an iSCSI storage repository and then a single virtual disk which resides in that storage repository. So the performance that we can guarantee to the backend SolidFire volume is effectively passed on to this one and only virtual disk. And this is the situation that we want to demonstrate here. So let's go ahead and switch back to the CloudStack GUI. I'll go over to the Infrastructure tab, click on View All for primary storage. Now I'd like to add a new primary storage. To do this, I'll go to the upper right and click on Add Primary Storage. In my case, this particular primary storage is going to be at the zone wide scope, so I'll click on that. The hypervisor is actually going to be for any. Now in this particular case, we're only using it for XenServer, but each and every virtual disk for this particular type of storage will be backed by its own SolidFire volume. And when you have that kind of a model, you can actually do that and support multiple hypervisor types simultaneously with the same primary storage. So if I have a virtual disk on XenServer, I'll need to create a SolidFire volume, put an iSCSI storage repository on it, which is done automatically, and then put my virtual disk within that storage repository. Now with the same primary storage, I can also use it for something like vSphere, where I would also create a SolidFire volume when I need to, put an iSCSI, or I should say a VMFS data store that's using iSCSI on that particular SolidFire volume, and then put the virtual disk, which is a VMDK file, within that data store. So a very similar concept to XenServer in that sense. With KVM, what we do is we actually create a SolidFire volume, and that volume is passed directly into the virtual machine that's running on KVM. There's no need to put a clustered file system on that in advance. You don't actually use a clustered file system in that particular arrangement. So here we have hypervisor is equal to any. I have my zone set up. I'm going to specify a name, let's see, SolidFire SF-1. For protocol, I'll pick custom. Now from the provider list, SolidFire just happened to be picked by default, and that is what I want. I want the SolidFire storage plugin. Now this is known as managed storage. You can click the box here, you can check the box, or you don't have to. In this particular case, the SolidFire storage plugin is always going to be for managed primary storage. So this particular piece of information, whether the managed checkbox is checked or not checked, is not actually taken into consideration by the SolidFire storage plugin. It just treats itself as managed storage all the time. So I'll just go ahead and check it anyways, just so we can visually see here that we're dealing with managed storage. Now the capacity bytes, I'm going to give us access to 2 petabytes worth of storage. Now this just means I'm allowing CloudStack to create volumes on the SolidFire cluster until it hits 2 petabytes, or I should say until it tries to exceed 2 petabytes worth of storage. The other constraining factor is the amount of IOPS that we give to each and every volume that's created on the SolidFire cluster in response to the need of virtual disks within CloudStack. So here I'm going to say, I don't know, 4.5 million IOPS. So we have 2 constraining factors here. We can use this primary storage to create SolidFire volumes to support our virtual disks until we try to exceed either the capacity bytes or the capacity IOPS. Now the URL field, which is where I'm at now, is a collection of key value pairs, and these are going to be very specific to the particular storage vendor. In my case, I'm going to select I already have it kind of cached here. I'm going to select this bottom one. And this really just provides information like what's the virtual IP address on the management plane of the storage cluster, what's the virtual IP address on the data plane of the storage cluster, what can I use to log in when I create volumes or accounts automatically. All of that kind of information is passed in here in a key equals value format. Now I'm going to leave the storage tags empty. At least we can do that for now. That's actually going to match the storage tags of my previous primary storage, which is the NFS SR. And I'm just going to hit the OK button. So this is pretty quick to add this particular type of primary storage. It doesn't actually need to go off to the cluster and do anything up front. It just records within the CloudStack database, in particular the storage pool table within the cloud database, information regarding this primary storage. So now that we have this up and running, let's go ahead and migrate the virtual disk of our one and only virtual machine. Let's migrate that from our NFS SR to this, I'll highlight it here, to our new primary storage, which is based on the SolidFire storage plugin, which is using a SolidFire cluster, of course, in the back end. To do this, I'm going to switch over and click on the Storage tab. Then under the Quick View area, I can click on Migrate Volume. Now this is one option. Of course, you could also click on the name of your virtual disk, and then within the options up top here, you could click on Migrate Volume. Now before I do this, let me scroll down a bit here. We can see we have a 20 gigabyte virtual disk, and at the bottom here, we have storage PS-1, primary storage 1. Now I guess just to refresh our memory on this, let me switch back to the Infrastructure tab, click on View All for primary storage, and we can see here, and I'll highlight it, under the Path column, we can see that this is an NFS-based SR. The path is Export Primary. So I'd like to get the virtual disk off of this, and I'll highlight it here, onto my SolidFire primary storage. Now to do this, we'll go ahead and migrate that through CloudStack's normal migration mechanism. What we'll expect to see is a new SolidFire volume that's automatically created on the SolidFire cluster. It's going to have the right size, the right performance characteristics. On that SolidFire volume, we will automatically create an iSCSI storage repository, and then within that iSCSI storage repository, we will copy the data in the virtual disk that's on the NFS storage repository to the new iSCSI-based storage repository. And so once that process has completed, as you would expect, the virtual disk will no longer exist on the NFS SR. It will exist on the iSCSI SR, and additionally, that virtual disk will be the only virtual disk inside of that iSCSI SR. And by doing that, we can then guarantee that the full performance, all of the minimum, maximum, and what we call burst IOPS of the SolidFire volume will be made available exclusively to that virtual disk. Now, of course, there's some operations that are going to go on that SR related to metadata, but for all intents and purposes, all of the performance of the SolidFire volume is going to be accessible for use by that virtual disk. Now, before we actually perform this migration, let me go back to our service offering. I'm going to click on the Service Offerings tab. So under Compute Offerings, we made our Compute Offerings CO1. I'll click on its name, and It was a very simple compute offering. We had a single CPU core operating at 200 megahertz and 128 megs of RAM. We didn't fill in, I'll scroll down a bit here, we didn't fill in anything around IOPS. And the reason I did that was to kind of demonstrate how you might migrate from a legacy environment that does not have IOPS controls to a more powerful environment that does have those performance controls. So in the older environment, when you created the compute offering and you didn't have access to these controls for IOPS, it made sense. You didn't fill in any of those values when you created that compute offering. Now, in the new environment, since we do have the ability to control performance for each and every virtual disk by making use of the SolidFire storage plugin in conjunction with the SolidFire cluster, we will want these values to actually be filled in. Now the thing is, if I just go into edit mode on this particular compute offering, we can see that we're able to change the name and the description of the compute offering, but nothing else. Not any kind of performance controls, nothing else besides the name and the description. So let me actually just cancel this. So to do this, we're going to actually go into the CloudStack cloud database, and there's a table that maintains information for disk offerings. We will update a few fields in that table for that particular disk offering, which will treat this as if we did actually enter in those values when we had created this compute offering. So let's go ahead and do that now. I'm going to switch over to my Windows VM, and inside of this I have access to my cloud database. Within that particular database, I'm going over to the disk underscore offering table, which is actually already visible on the right hand side here. And I'm going to find my compute offering, that's CO1. Now I know it's the last one I created, so I'm just going to scroll down to the way bottom. And I'll highlight the row here. This is the one we're interested in. I did have prior offerings that I had deleted before I made this video, but the row that's highlighted here is the one that we're interested in. Now, if I scroll over to the right-hand side, way to the right, we can see here there's a few fields that we don't have information for. We don't have the min IOPS, and we don't have the max IOPS. Now, if I go back over to the CloudStack GUI, and I'll click on Service Offerings. In the upper right, I'll click on Add Compute Offering, and I'm just going to scroll down a bit here. Quality of Service Type, QoS Type. There's a few options. I'll click on this combo box. We're interested in Storage Quality of Service. If I click on that, we'll see some additional fields fill in below the QoS type. I'm going to click on that now. So here's our new fields. There's this min IOPS that is of interest to us, max IOPS, and also something which I'll get to in a moment called Hypervisor Snapshot Reserve. So these are the three fields that we did not fill in when we created that earlier compute offering. And the reason I didn't fill them in then was because I was just trying to simulate a traditional environment where you didn't have quality of service controls, and so you would not have filled those in. You would have created a compute offering without that information, and then you would have spun up VMs that had their boot disks on storage that did not do any kind of quality of service. And so we're trying to get ourselves to migrate from that kind of environment to an environment that does have those quality of service controls. And so that's the reason why I didn't fill those in initially, because I was trying to simulate um, what a normal customer would do, having having built up a cloud without quality of service and now wanting to migrate to one with quality of service. So what we want to do is I'll switch back to our Windows VM that I have access through MySQL Workbench to the cloud database. And again, looking at the disk offering table, I've highlighted our compute offering that we created at the beginning of this video. And I'm going to go ahead and fill in minimum IOPS. So let's do something like, let's say 1,000 minimum IOPS and 2,000 maximum IOPS. Okay? So what that means is when a virtual disk is created on the appropriate type of storage that can support this, you would assign 1,000 4K minimum IOPS to that SolidFire volume and 2,000 4K IOPS for the maximum value of IOPS. So the minimum is pretty much what it sounds like. That is the guaranteed amount of performance that volume has. The maximum is sort of like rate limiting. It typically is an upper limit to how much performance we will allow you to draw from that particular SolidFire volume. However, it's more flexible than rate limiting in the sense, and we don't have it here as an actual control, but the SolidFire cluster has the concept of burst IOPS. So if you're actually running below your maximum IOPS, you're accruing what we refer to as credits. And if you need to, say you have a bursty workload and all of a sudden you need a whole bunch of performance, if the SolidFire cluster has that performance available, and if you've actually accrued a sufficient number of credits, you can not only go up to your maximum IOPS, you can burst above that maximum IOPS until your credits are expended, at which point you would then be drawn down at most to your maximum IOPS. But in general, just kind of I guess look at it as minimum is the guaranteed number, maximum is sort of like rate limiting, but burst makes it more flexible than rate limiting. So here we've got 1,000 and 2,000 for the minimum and maximum IOPS respectively. And if I go over to the right a little bit more, we see this Hypervisor Snapshot Reserve. Now I'm going to fill in 200 and then I'll explain that in just a moment. I'm going to hit the Apply button. Oh wait, actually it did not accept my value there, so let me cancel that. Let me go back into here, hit 200, hit Enter, and now I'll hit the Apply button. And we can see that it's ready to set the minimum to 1,000, maximum to 2,000, and Hypervisor Snapshot Reserve to 200. So I'll click on Apply. This was done successfully, so now I'll close it. So at this point, we can actually go back over to the the CloudStack GUI. I'm going to cancel out of this dialog. I'm going to click on the name of our compute offering, scroll down a bit, and we can see that we do now have 1,000 and 2,000 for minimum and maximum IOPS respectively, along with a 200 value for the Hypervisor Snapshot Reserve. So time to explain the Hypervisor Snapshot Reserve. Let's say, now we saw before, our virtual disk that we want to migrate is 20 gigabytes. So at first pass, you might think that would require a 20 gigabyte SolidFire volume to support that. The only problem with that is that it is not, the SolidFire volume is not passed in directly to the virtual machine as a raw disk. What we have to do from XenServer's point of view, and this is all done automatically, once we create the SolidFire volume, we have to put a storage repository on it. And that is going to require some space for metadata. And then within that storage repository, you can put your 20 gigabyte or whatever virtual disk. So we know our SolidFire volume has to be big enough for the 20 gigabyte virtual disk, plus some additional space for the metadata of the storage repository. But additionally, if you want to be able to take hypervisor-based snapshots, so not SolidFire-based snapshots in this case, which is also an option, but hypervisor-based snapshots, you would require even more space within that storage repository. So what this is allowing us to do is to control the size that we actually make the SolidFire volume on the back end. When I say 200 here, it's saying take the 20, in this case 20 gigabyte virtual disk, and then I want the SolidFire volume to be 20 gigabytes plus an additional 200% or 40 gigabytes of space. So 20 gigabytes for the original virtual disk plus 200% of 20 gigabytes, so another 40 gigabytes, and in total 20 plus 40 is 60 gigabytes. So whenever we create a SolidFire volume on the SolidFire cluster that's under the control of this particular compute offering, we will take whatever the virtual disk size is, and effectively in this case it's going to be tripling it. It's going to be taking the original size and then plus 200% of that original size of the virtual disk. So our 20 gigabyte virtual disk is going to be placed within a storage repository that's 60 gigabytes. The SolidFire volume will be 60 gigabytes. The storage repository will be placed on that, and then the 20 gigabyte virtual disk will be placed within that storage repository. Now, the good part is you're not actually taking up any additional space, any physical space, except for just a hair of metadata when you create a SolidFire volume that is 200 gigabytes versus 20 gigabytes. In fact, actually, a 20 gigabyte SolidFire volume versus a 200 gigabyte SolidFire volume is going to start out at the same amount of actual consumption on the SolidFire cluster. It's just that you could actually grow the one volume up to 200 gigabytes, whereas the other one can only go up to 20 gigabytes. But initially, they start really with the same utilization of capacity on the SolidFire cluster. So it's not like we're really taking up space here that can't be utilized elsewhere within the cluster. So that is kind of a quick overview of what Hypervisor Snapshot Reserve does. Now let's go back to our view of the database. Now we've updated the disk offering. Let's go over to, and I already have this up on a different tab, we're going to go to the volumes table within the same database, the cloud database. And I'm going to scroll down to the way bottom again. I know it was the most recent virtual disk that we made. I'll highlight it. We can see it's root-10. And if I actually go over to XenServer, we can see within our NFS SR, it's highlighted here, root-10. So that is back, I'll go back to the, actually I have to go over here. I'll go back to our view of the database. That's the row that we have highlighted. Now, since this was created from the compute offering before we edited the compute offering to specify the minimum, maximum, and hypervisor, the minimum, maximum IOPS and the hypervisor snapshot reserve, we don't actually have those three fields specified for this particular volume. I'll scroll way to the right and we can see here what we actually do have specified. All right, so the way it turns out, we have null for minimum, null for maximum, and 0 for hypervisor snapshot reserve. What we want to do is we're going to fill in those same values. So that was 1,000 and 2,000 for min and max IOPS respectively. and then we had 200 for the Hypervisor Snapshot Reserve. Now I'm doing this all manually within the database. This can all be scripted to go through and update your compute offerings and then the volumes that are associated with those compute offerings. Or if you're migrating data disks, the same concept applies. You could script something to go in and update your disk offerings and then go in and update all of the volumes that were instantiated by using those disk offerings. But in this particular case, I just have the one compute offering, the one virtual disk. I'm just going to go in and manually enter these values. So now that I have them, I'll click on the Apply button. We can see here our minimum 1,000, maximum 2,000. Hypervisor Snapshot Reserve is at 200. So this looks good. I'll click on the Apply button. That was executed successfully, so I'll click on Close. And at this point, we should be able to go over to our CloudStack GUI. I'll click on the Storage tab. We just have our one virtual disk, the root or the boot disk of our virtual machine. I'll click on its name, and we can scroll down a bit here. For minimum IOPS, we can see we're at 1,000, and maximum IOPS we're at 2,000. So this looks good. I don't believe we actually specified the Hypervisor Snapshot Reserve in this particular view of the data, so we shouldn't expect to see anything there. So now we're basically all set. Let's go and migrate this to SolidFire storage using a very simple process. All right, to perform this migration, let's just go up to the options we have here. We can see the far left one is migrate volume. I'll click on that. There really is, in my particular situation here, just a single suitable storage pool. I can click on the combo box here. In a larger environment, you might have, of course, many more options, but here we just have the one. It is suitable as the GUI informs us. I'm just going to go ahead and click on the OK button. So what's going on here is let's go over to the SolidFire GUI. We can see this directly. I'll click on that tab. Now we're inside of the SolidFire graphical interface. We're on its volumes tab, in particular its active volumes tab. This is an old view. I don't have any volumes. It's kind of a brand new SolidFire cluster. I'm going to hit the refresh button here, and we can see in a moment we have a new SolidFire volume that is placed in a SolidFire account. So the SolidFire cluster, all of the volumes are associated with a particular account. So very much like CloudStack, how you have different accounts that own resources, in a similar fashion, the SolidFire cluster is broken up into accounts that own volumes. So what we do here is the SolidFire plugin will automatically create a SolidFire account to own this particular SolidFire volume. That SolidFire account that we created will be mapped to a particular CloudStack account, the CloudStack account that initiated the action, effectively the CloudStack account that owns that virtual disk. So if there already exists a corresponding SolidFire account, then we're fine. We'll just make use of that. Otherwise, we'll automatically create that and associate it with our newly created volume. As we can see to the right, our size is what we would expect. Our virtual disk is 20 gigabytes. We had a 200% Hypervisor Snapshot Reserve, so 20 gigabytes plus 200% of 20 gigabytes, or 40 gigabytes, is 60 gigabytes. Now, the only seems like a discrepancy, but it's not. It's just the way the SolidFire interface does a base 2 reckoning of the number of bytes versus, let's say over here, let's go to the XenServer graphical interface. I'll click on my virtual machine for Windows, go to XenServer, and we can see it's up and running here. I'll click on our new storage repository, and you can see here it's 60 gigabytes. It's just really the difference between base 2 and base 10 reckoning of the number of gigabytes. So those are consistent. Let's see over here. We can see we have 1,000, what are 4K minimum IOPS. We have 2,000 4K maximum IOPS. And here's our burst. Our burst is set at 3,000. And so back when we added primary storage to CloudStack that was based on the SolidFire storage plugin, there was that URL field that had a collection of key value pairs that we kind of glossed over. One of the values told us how to compute the burst IOPS based on the max IOPS. And what that is a multiplier. We had the value 1.5 in as that multiplier. So what it does is whenever we create a SolidFire volume, we take the max IOPS for it and we multiply it. Oh, you know what? Actually, in this particular case, I think our multiplier, oh no, it is, that's right. It's a 1.5 multiplier. Yeah, so here we are, 3,000 for the burst IOPS. So we just take whatever the maximum IOPS is. In this case, we've said multiply it by 1.5, and that will account for the size of our burst IOPS. So this all is looking good. Let's go over to XenServer and see what's going on there. We should expect, as we just previously saw, that we have a new storage repository. Okay, so here we are in the XenServer environment. I've already highlighted it. This is our new storage repository. If I click on the storage tab, we can see that we have our virtual disk root-10 inside of this storage repository. It's the right size as we would expect, and it is in fact attached to that virtual machine which we created at the beginning of this video, i210VM. And if I go to the original SR, which was our NFS SR, I'll highlight it now, we can see that we no longer have a root-10 within this SR. So it has been migrated to this newly created SR. And in fact, this is going to be the only virtual disk within this particular SR. And so this virtual disk effectively gets all of the performance characteristics that are associated with our SolidFire volume. For example, we said 1,000 4K minimum IOPS. So effectively, we get that 1,000 4K minimum IOPS for this one and only virtual disk. With a slight caveat that there are going to be some metadata operations performed on the SR, things like that. But for the most part, all of that performance goes to this particular virtual disk. So now if this particular virtual disk is servicing some kind of business critical workload, you can be assured that it will get the performance that you specified. And you won't have to worry about it competing with other virtual disks for the IOPS of the back-end storage. Let's now switch back over to the CloudStack GUI. So this is the SolidFire GUI. I'm just going to click on the CloudStack tab. And here we are within our storage tab for this particular virtual disk, root-10. If I scroll down, we can see that it is now on storage SF-1. And just to kind of double check this, I can go to the infrastructure tab, go to view all on primary storage. Let's go to the original SR, PS-1, and then go to view volumes. Now remember, this only shows us user virtual disks. We actually do have some system VM virtual disks on this particular primary storage, but they won't show up in this view. So this looks correct. If I go back using these breadcrumbs to the primary storage area, click on the name of the SolidFire based primary storage, and then go to view volumes. We can see here that we do in fact have root-10 on this particular primary storage. So I'd just like to take a few moments to kind of maybe clarify a little bit more about that Hypervisor snapshot reserve value. Let's go to our virtual machine up in the Instances tab. And I want to, let's say I want to take a snapshot of the virtual machine. So I say take VM Snapshot. Actually, before I do this, let me switch back over to my Windows VM, and we can see within our newly created iSCSI-based storage repository that we just have root-10. So this is the virtual disk that we migrated to this storage repository that resides on our SolidFire volume with guaranteed performance. Now let me go back to CloudStack. We're in the Instances tab, and let's say I want to go to take a VM snapshot. So here I am, I'll click on Take VM Snapshot. I don't really care about the name and the description here, so I'll just hit OK. Now this will just take a moment, and it will take a hypervisor snapshot of the metadata for the virtual machine, as well as a snapshot of, in this case, its one and only virtual disk. So we can see from the notifications up top here, we were successful with that. Let's now go back to where we were in XenServer, and we can see that we actually have two virtual disks here. So I'll highlight this snapshot, and then this is the active virtual disk. Now, these are essentially part of the same virtual disk from the point of view of our virtual machine. So what I wanted to note here is the fact that we took that hypervisor snapshot of this virtual disk means that we will require additional space within that SR. And that's the value of the hypervisor snapshot reserve field, is to allow you to take these hypervisor-based snapshots and have enough space within the SR. Additionally, we do need a small amount of metadata space for the SR itself. But that is the main reason. Metadata space of the SR itself, along with the amount of space that is required to store these hypervisor-based snapshots if you do make use of that take VM snapshot feature. So here we can see what appear to be multiple virtual disks, but they're really just associated with the same virtual disk from the point of view of our virtual machine. Now we can go back over to CloudStack. I'll click on the name of our virtual machine, view snapshots. Now we just have this one snapshot. Just going to go to the quick view column here and delete it and say yes. And as soon as this has completed, we can go back to XenServer and just confirm that we just have that one virtual disk in our SR. So here we are. Deletion of the VM snapshot was successful. Let's go back to XenServer, and here we can see we now just have that one virtual disk within our SR. And I'll just switch back over here to the General tab again and highlight the appropriate row so we can see 60 gigabytes for the SR itself. That's because of the 60 gigabyte SolidFire volume. 20 gigabytes is allocated. That's considered for our virtual disk. Now when we look over here to the side, we see 20.1. That additional 0.1 is for the metadata of the SR itself. So kind of a quick pass through. That's why the hypervisor snapshot reserve field exists. It's to give us this additional flexibility. Now the final area I'd like to touch on before wrapping up this video is around using CloudStack's volume snapshot feature and how that works with this particular type of primary storage. So to do this, let's go back over to the CloudStack GUI. I'll click on the Storage tab. Now let's say we want to take a volume snapshot of this particular virtual disk. Now traditionally within CloudStack, what happens is you would take a hypervisor-based snapshot and then copy that read-only virtual disk to secondary storage. Now that is time-consuming from a data copying over the network standpoint, and it also, of course, takes up additional space on your secondary storage location, well, NFS or some kind of object storage. What we do here is a bit different with regard to volume snapshots and managed storage with the SolidFire storage plugin. Before I do it, let me quickly switch over to the SolidFire GUI, and I'm just going to refresh this so we can see where we're currently at. Pretty much it looks like the same exact state as we were when we were last here. I just wanted to note that we see snapshots is equal to 0. In a moment, when I take a CloudStack based volume snapshot, we will see that snapshot's number increment to 1. So let's go ahead and do that. I'll switch back over to the CloudStack GUI. On the Storage tab, Volumes View. Here's our one and only virtual disk residing on SolidFire storage. In the Quick View column, I'll say take a snapshot. Let's just give it some kind of name, snapshot 1, and I'll hit the OK button. Incidentally, whether you check this box or not doesn't have any particular effect on this type of snapshot. It's a very fast process anyways, and so there's really no need for this async backup feature for this particular type of primary storage. So I'll hit the OK button, and in just a moment we'll have our snapshot. So here it is. If I switch over to the snapshots view, we will see that we do have our snapshot, SS-1. It's of this particular root-10 volume, that virtual disk. And now if I go back to the SolidFire GUI and I hit the refresh button, now before I do that, we can see snapshots is equal to 0 on the old view. Now I click on that. Now we have one snapshot. If I click on that, we can see more information about it from the point of view of the SolidFire storage cluster. Now from CloudStack's point of view, and I'll switch back to CloudStack, this is a volume snapshot that resides on primary storage. Now it's stored on the SolidFire cluster as a SolidFire snapshot, which is very space efficient, and of course, as we saw there, it was very fast to take that snapshot. Now when you want to make use of it, you just do what you do for normal snapshots. You go to the Quick View column, and you can create a template based on this. So that would be a template that resides on secondary storage. So we'll automatically go through the process of getting that data, a copy of it, from the snapshot on the SolidFire storage cluster to your secondary storage. And then you can use that template just like you would any other template. You can also create a volume from this volume snapshot just like you would any other volume snapshot. So basically, as a quick overview, what we saw here was a way of migrating your virtual disks that reside on traditional traditional CloudStack storage, perhaps NFS, but it could be a different type of primary storage. We wanted to get our virtual disks off of that in an online fashion onto SolidFire with guaranteed storage quality of service. And so we went through the process here of migrating from the one storage to the other in an online fashion, so it's not disruptive to any of your customers. And then when you have it on the SolidFire storage cluster, you have the ability to change your performance without any kind of downtime in a very quick fashion. So if you decide you later want, let's say, not just 1,000 4K minimum IOPS for that particular virtual disk, maybe you want to increase that to something like 1,500. Well, you can do that through CloudStack's GUI or directly through its API. You can change that performance characteristic in an online fashion. Those kind of API calls are just passed on directly to the SolidFire storage cluster, which makes those changes, and then within a few seconds you'll have your virtual disk operating at the new performance characteristics that you just specified. So it's a very flexible way to be able to guarantee the performance of your workloads. The only thing to keep in mind with XenServer is that XenServer has limitations around the number of storage repositories that it supports per compute cluster. So this has been tested at around 500 to 600 storage repositories per XenServer compute cluster. Once you start getting up above that 500-600 range, it does become slower from XenServer's point of view to create the next storage repository. And if you have to reboot a host that has access to 5 or 6 or 7, 800 storage repositories, it does take it longer to boot up. So that is the one main consideration, is scalability on the XenServer side in terms of the number of storage repositories that it can reasonably support per compute cluster. Anyways, but thank you very much for watching this video, and hope you enjoyed it.